Hello everyone, welcome to my YouTube channel Excel Achievers. Last time we were solving the questions of HP Set Math 2024. Now let us proceed with the other next questions of HP Set 2024. This question number 41, came in the group B of HP Set 2024. And this is the question of complex analysis. Let's see how we solve this question. Now, we have given z square minus 1 is equal to mod z square plus 1. We know in complex analysis z is equal to x plus iota y. So z square must be x square minus y square plus iota 2xy. Now, the mod z of x is x square plus y square under root, and mod z square will be x square plus y square. Also, z square minus 1 will equal to be x square minus y square minus 1 plus iota 2xy. Now let us put these values, this value and this value in here. We get x square minus y square minus 1 plus iota 2xy mod equal to mod z square is equal to x square plus y square plus 1. Now let us remove this mod also. What we will get? X square minus y square minus 1 whole square plus 2xy whole square is equals to, there has to be a square root, but I took the square root to this side, so I get x square plus y square plus 1 whole square. Now let's see. Now I know the formula a plus b plus c whole square. What I get? x4 plus y4 plus 1 4 plus, when I multiply this and this, I get 2y square minus 2x square minus x square y square, which is equal to this. And I'm sorry, there is one more thing. Yeah, here is 2 and also plus 2, it will become 4x square y square, and this is equal to this one, x4 plus y4 plus 1 plus 2y square plus 2x square plus 2x square y square. Now let us solve this equation. I know that x4 will cut x4, y power y 1 to 1, 2y 2y, and this will cut down. We have left with minus 2x square is equal to 2x square, or 4x square equal to 0, or x is equal to 0. So what I get, that z is equal to x plus iota y. So x is 0, I left with iota y. So our this equation mod z square minus 1 equal to mod z square plus 1 lies on imaginary axis. So our right answer is the imaginary axis. Now let us solve the next question. Okay, So this is our next question for mode z less than 1. The sum of series z 1 minus z plus z square 1 minus z plus z cube 1 minus z plus so on is. So I can just consider it as like a normal real number series. So z 1 minus z plus z square 1 minus z plus z cube 1 minus z plus so on. Take 1 minus z common. What I will left with z plus z square z cube plus so on, right? Now I know that mod z is less than 1, so which formula I can use is GP series, where a is the initial value and r is the difference. So I go with sum a 1 a upon 1 minus r. So this what I will do, I will do go with the same. So z equal to a 1 minus r yani 1 minus a. This and this cancel out, I get z. So my right answer is option this one, z. Okay, so let's begin our next question. The question number is 44. Let ux comma y is equal to e power minus x, x sine y minus y cos y. The function v x comma y is such that f of z u plus iv is analytic. Okay, so solution क्या है हमारे पास? You can clearly see that we have given real part. This is the real part, and also we have told that the function is analytic. If any function is analytic, then it satisfies CR equations. CR equations. What are the CR equations? Ux is equal to Vy and Uy is equal to minus Vx. Let us take any one of them. I am going to take this one. If u given e की power minus x, x sin y plus y cos y, then ux means du upon dx, and we get the differentiation. So first I will differentiate minus e minus x, x sin y minus y cos y plus e minus x, and x means sin y, and remaining these are in y, so these are 0. So let us rewrite it. What I get minus e minus x sin y minus minus plus e minus x y cos y plus e minus x sin y. Now we know that by CR equation ux is equal to Vy. That means this equation is equal to Vy. Now this you can see this Vy in a differentiation. What is the opposite of differentiation? That is integration. So let us integrate this Vy with dy. V of y dy integration minus e minus x, x sin y dy plus e minus x y cos y plus e minus x, this is also an integration, sine y dy, and here is also dy. Okay. Now you can see that the functions which have x, those are constant, considered here constant. Okay, so let us take them out common, and I left with sine y dy plus e minus x y cos y dy plus e minus x sine y dy. Okay, so integration of sine y is equal to minus cos y. So minus x ex minus ex cos y plus e minus x. I know that there are two different, so I will use eyelet. By eyelet, I algebraic y and integration of cos y sine y minus integration sine y dy bracket close plus e minus x minus cos y, or I make it more simpler, minus x e minus x cos y plus e minus x y sine y minus plus e minus x cos y, and this is minus e minus x cos y. Clearly I can see that this cut with this subtracted, we left with e power minus x common, minus x cos y plus y sine y, right? So I think I have done a little blunder here, the integration of sine y. Okay, so I did the mistake here. Why my answer come in negative? That here is a negative sign. I didn't take out the negative like this. This should be plus here. This is plus and this is plus. So our right answer is y sine y plus cos x, and this is our right answer. Last option is our right answer. Now let us begin with our next question. This is question number 47. The Mobius transformation which sends 0 to 0, 1 to iota to 1 and infinity to 2. So how we will solve this question? In these options, whoever satisfies these 0 to 0, iota to 1 and infinity to 2 is our right answer. Let's check option 1, 2z, z minus iota. Okay, so put z is equal to 0. When I put z is equal to 0, I get 0, 0 minus iota, which is 0. So this is true, 0 to 0. Next, z equal to iota. So what I get? 2 iota, iota minus iota, which gives you infinity, and which is not correct. Not correct. Why? Because here is given कि iota should be equal to 1. So option 1 is wrong. Let's see option 2. Option 2 is z plus iota, z minus iota. Now first put z equal to 0. When I put z is equal to 0, I get minus 1. So option 2 is incorrect. Let us check for option 3. Option 3 is given 2z upon z plus iota. If I put z is equal to 0, I get 0. Okay, so 0 to 0 is correct. Z equals to iota, I get 2 iota. Iota plus iota, 2 iota, which gives you 1. So this is equal to iota to 1. Last is infinity to 2. So z is equal to infinity, or you can write it as 1 upon 0. Okay, what I do, I take 2z, z plus iota. Let us take z common. I left with 2 upon 1 plus iota z, and I'm going to put the value of z. So I am getting z value infinity, so I am going to have 2 1 plus 1 upon infinity gives you 0. So 2 upon 1 2. So all the options of z is equal 0 to 0, iota to 1, and infinity to 2 are satisfied by option 3. So this is correct. But let us check option 4 also, so that it who knows, that option 4 might be right also. So it might possible that this is a multiple select question. Let us check. Z minus iota upon 2z. Put z is equals to 0. So I get minus z upon 0. So this is also incorrect. So our right option is third option. Third option is our right option. Okay, so let's follow our next question. Our next question is,